right, it's being broadcast to all people, which I assume all people can hear now. Participants,
Yep.
It's climbing up a little bit, it looks like, as people are joining. What I'm not exactly sure about is I'm pretty sure everyone can hear us right now.
Okay. Well, thanks, Charlie. Let me go ahead and introduce you and give some people background on today's webcast. My name is Dan Vlamis, and I'm the host for today's Analytics and Data TechCast that's going to follow. And I'm associated with the Oracle and BIWA user community, which runs these Analytics and Data TechCasts. We're going to have a great speaker today, Charlie Berger, product manager on Oracle machine learning, along with Siddesh and Dhvani from Oracle are going to talk and demonstrate about wine analytics. Something I'm especially interested in is how to pick a good wine for under $20 using the Autonomous Data Warehouse, machine learning, and Oracle Analytics Cloud. After that, we're going to have a brief Q&A. You can reach Charlie at his Twitter handle at CharlieDataMine. He's a frequent tweeter, and at charlie.berger@oracle.com. All these Analytics and Data TechCasts should take about 30 minutes, including time at the end for Q&A. So you should find at the bottom of your screen a button that you can click on to ask questions, and we'll try and handle those during the webinar if appropriate, and otherwise at the end of the TechCast. At the end, the TechCast is going to be recorded and posted on the TechCasts page. You'll find that at Analytics and Data Summit, all one word, .org/TechCasts. That's where we're putting all of the material for all of these TechCasts. This information is going to be recorded, and you'll get that information shortly following the TechCast. We're also going to put a PDF of the presentation on the page and put the TechCast recordings later with the hashtag #AND _TechCasts. Everybody that's listening to this, if you have some knowledge, expertise, tips, or tricks to share, we encourage you to submit them on the TechCast page, and we select those. We're doing these about every 2 weeks, so you can submit those, and we'll look through them and schedule TechCasts coming up. You'll find the upcoming schedule on that page. With that, let me go ahead and turn things over to Charlie, and you can start the presentation. Thanks, Charlie.
All right, thank you, Dan, for that great introduction. Hi, this is Charlie Berger. I'm the Senior Director of Product Management for Machine Learning, and I'm honored to be here with Dhvesh and Dhvani, who have been working with me on this. And the scenario that we're trying to show in sort of how to use the technology to solve problems is sort of an artificial one, but it's also sort of real. The idea is that we get invited to go to a party, and we want to bring along a bottle of wine. But there's so many different varieties, so many different bottles of wine, so many different countries, so many different prices. And maybe we don't know the people that well, and we don't want to spend that much money. So we're looking to try and bring a really good, tasty bottle of wine, one with perhaps 90 points rating and above, for even under $20 if we can get away with it, right? So we want to try and do that. Not all bottles of wine are labeled, right? Only a few are really rated officially. So what we're going to see if we can't do is use the past ratings of some bottles of wine and look at the variety, their price, their country, various different pieces of data, and see if we can't make some predictions. So let's jump into this. It's meant to be informative, learning how to use the product, some of the features and functions, and also a little bit of fun. So let's see if we can do that now. So Oracle always has a safe harbor statement. And the TechCast objectives here are really to share a simple autonomous data warehouse and Oracle machine learning and Oracle Analytics combined use case, where we're going to use the autonomous database and Oracle machine learning. We've imported some data. Now the data is coming from UC Irving data set, also from Kaggle. They've posted it for some Kaggle competitions. We're going to import the data, which we've actually already done. We're going to explore the data using the notebooks. We're going to try and find what are the key variables that are really most influential on finding a good bottle of wine. Is it country? Is it price? Is it variety? What is it? You know, years old, whatever. We're going to build some predictive models. I think we actually only build one, a random forest inside the Oracle Autonomous Database. We're going to apply that model to some additional wine data, and we're going to take all the predictions and insights. We're going to review them a little bit in the autonomous data warehouse with the notebooks. But then I'm going to hand it over to Siddesh and Dhvani, who are going to further investigate the insights and the predictions using Oracle Analytics Cloud, because they have maps, special visualizations, and so on. So the process we're going to start down is this business understanding, data preparation, and so on, sort of what's called the CRISP DM method for data mining or machine learning, and we'll just kind of walk into it. As I said, the data and the examples that we're using, they're on Kaggle, so you can go to these links. They're in the presentation. I will, while Dhvani and Siddesh are talking, I will post these into the chat window, so you'll also have them there. You can also get them out of the PowerPoint that we'll post. We've also posted this notebook that we're using. It's up here in an Oracle database examples in GitHub, so you can download that. It's Picking a Good Wine for $20 or so. So that was 39 seconds ago last night, I guess. So I have this set up just as a few screenshots, just because you know how demos go. Sometimes things break, and just to make sure that we get through it all, I took a screenshot of everything, and we can come back to this if if the cloud gets cloudy today or whatever. But let's hope that it doesn't. It usually is quite working just fine. But a couple of these things I'm going to skip over. So here we've already logged into our Oracle Autonomous Cloud account, and I've come into my dashboard, and I have a few different facilities available to me: the Oracle Analytics Cloud that I'm going to leave to Siddesh and Dhvani to show, and then the Oracle Autonomous Data Warehouse Cloud, which is where I'm going to log into. I log into here, I go to the Open Service Console, and then I come in here. I've already created an autonomous database a while ago, and it is live and available, and it's in one of my other windows. So I can see that it's available, nice and straightforward. I go to the Service Console here, click on that. I'm logged into the Ashburn facility, but I can go to Phoenix or a bunch of other different sort of back-end servers. I click on the Service Console, and this is something you go through usually when you set it up. So I am also the administrator for my instance of the cloud and the Oracle machine learning users. So when I come into here, if I go into administration, there's a number of things I can do. And many other TechCasts will cover this, and other Oracle presentations and demos will cover this. But some of the things that are important to do is download the client credentials, so I can make a connection, let's say, from SQL Developer, so I can upload data and such. And also, I can manage my Oracle machine learning users. So I have to set up Dhvani and Siddesh as users, and anybody else with whom I am collaborating, because this is collaborative machine learning software here, all set up on the cloud using the Zeppelin notebook as we sort of work our way through data-driven problems. And so I set that up. I've got a number of different users here, and I'm in here, Charlie, and then I come in as Charlie and do my work. But before I do this, I just did want to point out one upstream step that I've done already. I've logged into this cloud instance, this Autonomous Data Warehouse Cloud instance, using SQL Developer with that client, that login credentials, or the wallet is what they call it. Once I establish that cloud connection using the wallet and SQL Developer, then I can go use SQL Developer and import tables and such. Now, this is the data I'm bringing in here. It's the wine reviews, 130,000 records data set. I brought it in as a CSV file. Of course, you could bring it in smarter ways through cloud storage objects and such. If I'm doing production data, the data would already be in the Oracle Autonomous Database, likely. So here I come into here, and I have these notebooks and different things. So at this point, I'm going to vector out of here and go back over to hopefully what's working right behind the window over here. I'm going to move this guy a little bit out of the way, and over here should be my notebook. So I've logged in. I had a number of notebooks, and I have logged into this particular notebook here, and it's got a name. And notice I have some other controls up here. I just want to kind of review these things quickly because they're kind of important. I have interpreter bindings. So these are the connections from the Zeppelin notebook back to the server side. And right now it's all SQL and Markdown language. Now in our product direction, we'll add interpreters for other languages. Okay, that's something that's coming. We've talked about that. Python and then R. We support R on premise already, do a great job of that, but adding it into the Autonomous Data Warehouse is something we still need to complete. And then we're also adding support for Python, so I could access the same functionality using a Python language or make callouts to Python. And that too is work that will be on premise relatively soon, and then also on cloud in these notebooks relatively soon. So I don't want to be too specific about relatively soon, but then the interpreter bindings will add additional bindings. I can also export this notebook. So if I just go over here and export this, notice it's dropped down over here in my lower window, and I could, put that up in GitHub, which is what I've already done. I can clear output. I can clear the notebook. I can run all paragraphs, so I can just go off and run that. And there are other settings over here about connection groups and notebook sessions and things like that I'm gonna ignore for the moment. Now, in version 1 of this Oracle Machine Learning Notebook, it is largely a type a little bit of code kind of a user interface. But there is, let's see, I guess I forgot to, I did want to show something here. There are a bunch of example notebooks that ship with the product that I highly recommend that you take a look at. So these are things that we've created. Actually, I think I created all these things. So doing anomaly, so they're very simple is my point. So anomaly detection, association rules, attribute importance. And what I'm doing is kind of working off this classification predictions one, because a lot of things that you do in machine learning are often boil down to classification type of problems. So I've modified a previous notebook, and I've done a few other things here. Now, I just want to show some of the stuff of how that works. Here, you're working in Markdown language, and I can show this, I can run it, and so on. And there it is, and I can hide the editor. Now it looks a lot prettier, because the nice thing about this is I can tell a story, and I can share my results, collaborate with others, even insert pictures, do kind of cool things like this. And in terms of a training material or passing along my knowledge, I'm kind of doing a lot of that right now, right? Because I'm documenting everything here. So I have this 130 wine reviews, 130,000 records, and these are the variables that I have here. Not a lot of variables, and I have points and such, and I can kind of sort these guys based on, well, it's 96.1. That looks pretty tasty. But I can go through all this wine and all these variables about wine here in the tabular view. I can also choose to do graphical kind of use of this. So if I wanted to do that, I can visualize in different ways. I already have a few graphs already set up here, so I'm going to continue on down here. Now this is already showing something that I wanted to not show initially. So I had saved that notebook showing something else, but here's the distribution of the different flavors of wine. Now I may want to do some basic visualizations here. Now this is not nearly as powerful as what you're going to see from Dhvani and Siddesh, but if I want to go through here and look at the way I've set up this problem where I'm looking for these higher value, higher point wines, I'm looking to find a real sleeper of a wine that is only $10 that is likely to be a 92 point wine or something like that. So that's what I really want to do here. And there's some graphics. So that's how I set up my problem. There's some graphics that I can do here that are kind of simple, but if I get in a little bit too complicated here, I start to run into some problems, and we have such greater functionality in OAC. So I'm going to defer some of my graphing for later on once I've done my predictive modeling. Now, I'd like to display the count of wines by country in descending order. So some of these things you're typing in SQL, and as we go forward, we're going to sort of have accelerator buttons that do more of these things and have more and more automation. But in this initial release, that's what it does. And if you're comfortable with a certain amount of SQL, you can do this rather easily. And you can use the templates and this code snippets that we ship with the product. Another nice thing about notebooks is you can also do these things with these drop-down lists over here. So now I want to see, compare the wines of different countries. And I have a graph here where I'm showing the amount of wines from different provinces or different areas. And I might say, well, I'd like to see that from Australia. And it can run off and do another version of that. I can compare that to Spain or to Germany. So I can have these little sort of syntax here, which gives me drop-down lists. Now, I'm going to use that later on to make my predictions and say, well, likelihood of this, likelihood of that. Notice also in these notebooks that I am not necessarily showing the editor. Maybe I am, maybe I'm not. It's my decision. And I can change the width of these little paragraphs to have them kind of lay out differently if I want to. So I've done a certain amount of analysis here. I'm getting closer to the point where I want to do some machine learning. Here is where I want to create a new table called wine reviews 130K, but without the points attribute. So when I build the model, I don't necessarily want to say, well, if it's 94 points and above, then I predict it's going to be greater than 92 points. So I want to actually just simply delete that from the input data set. Then I show the resulting table just to sort of prove that I did it. Then I come down here, and the first thing I want to do is run this attribute importance. That's where I'm going to say, well, show me what are the most, I'm building up the anticipation here. What are the most powerful variables for finding a good bottle of wine? And one of the things I want to do here, just for repeatability purposes, is drop any previous, objects or settings tables, things like that. In the graphical user interface version of this, obviously the GUI would take care of more of those kind of things when we get that available to you. But right now, more of a scripting kind of thing, I am doing that. And here's where I'm actually building the model. So I always say it's easier to teach it's an easy path, I think, not that easy, but a little bit easy for a person who's comfortable with SQL and machine learning. I mean, comfortable with SQL to learn machine learning. So here we've done that. It's 6, 7, 8 lines of code here. That's all it is. You have templates. And we've done a very powerful thing. We've run a supervised learning model using the minimum description length algorithm. So I've done that, and now I'd like to visualize that. So here I say, well, select again, but now show it as a table. As a bar chart or a pie chart. So it's very straightforward. I get to see, lo and behold, wow, price is the most important influencer. But I'm a cheap guy, right? I don't want to spend too much for my bottle of wine I'm bringing to this party. So I want to keep on going and do a little bit more analysis. Here, I'm going to do a lot of sort of behind the scenes work over here. Now I've covered it all up to make it look a little bit sort of simpler, but I have to build a classification model, generate a lift for test results, and apply the results. So I'm dropping my previous settings, I'm dropping my model, I'm dropping my results, I'm dropping my lift chart. I'm training the data, I'm splitting the data into a training data set. So I'm taking the wine data and I'm splitting into a 60% randomly selected sample, and the rest of it is a holdout sample of 40%. I am setting the settings tables for automatic data preparation on. I'm going to use a random forest algorithm. So these are the things that in the GUI on premise are all done for you. Here we're using templates and scripts and such to sort of edit these to make it sort of simpler for people. And if I just run this thing, I can run it thusly, and it's now just running a random forest algorithm completely parallelized inside the database, and it's building my model. So that'll finish in just a second here. I'm going to hide the header so we just kind of see the results, and it'll finish, and it'll just say it's done. Now, I've already run, I'll just keep going because I'm watching the clock tick by here. This usually takes 20, 30 seconds maximal. Now that I've already done this, I have a lift chart that I've done before, so I'm just going to show this lift chart here while we're waiting that other one to finish. So I can show the lift chart in different sort of ways if I want to, as a line plot, as a lift chart or whatever. And this guy should have finished by now. I'm just a little bit nervous about what was, I did something else there to slow that down. But so now that we've made our predictions, we can see that we've predicted the probability of each of these different IDs being greater than or less than. And I can use this clever little drop down thing over here as well to kind of say, show me the less than 90 points, show me the greater than 90 points. I'm going to go back up here and make sure that other thing is finished by now. Oh, he still isn't finished, so something has sort of surprised me there. Now, let's focus on the wines that have been predicted to be greater than 90 points. So here's my greater than 90 points. I do a query, I see the results, but it's tabular, right? I might want to see this in a little bit more of a visual way. So I could go up here and see different bar charts, pie charts, or some of that. I've done a little bit of that already. So I've come up here and said, well, let's see the wines by country grouped by, what happened there? By country grouped by, lost my connection or something there. I was having problems, just so you know, I was having problems with the internet this morning. Kind of got locked out on my computer for a few minutes too. So that was maybe some of what was involved here. But let's go down here to the bottom, sort of reboot that, get down here to where we are. And I want to turn this over to Siddesh and Dhvani in a second here. So I'm gonna go down to here. I'm going to get rid of this settings. I'll just show you the graph that I've done before. This is a graph of the predictions grouped by variety and grouped by country. So just waiting for this guy to kind of catch up to where I am. So there they are. And I can do a certain amount of this. And in the end, I've built a predictive model that says the probability I think is right here, 39% probability, 2% probability, and so on. So this is kind of a lot of data. There's 130,000 bottles of wine here, approximately. And I'd like to do some further analysis, but I first want to say, see, machine learning was pretty easy. Let's celebrate with a glass of wine. I'm going to kick back with a glass of wine and turn this over to Dhvani and Siddesh. But before I do that, I'm just going to sort of create my output table. I've done it here. I've done it here. My output tables are available, and there they are for Siddesh and Dhvani to take it on to some further analysis. With that, I'm going to stop sharing, look at the queue, look at the questions I'll try to answer while they're presenting. And Siddesh and Dhvani, maybe you want to take it away.
Thank you, Charlie. That was a wonderful demo on OML. So now that we have seen how to create and build models in OML and visualize data, let's take it further and visualize the data in OAC. So before we do that, how do we get the data to visualize on it? It's very simple to connect OAC and ADW. So this is the OAC dashboard, the home page. You click on Create, Connections. And then here is the Oracle Autonomous Data Warehouse Cloud. And I'm give a name. Client credentials is the wallet file that you get when you create an ADW. It's on the page where you download the wallet file. So here is my wallet file. Username and password are the same that you use to log into OML. And the service name is you choose between high, medium, and low. It depends on what performance and concurrency level you need. And just click on Save. That's it. So the connection to your ADW has been established from your OAC. So now you can import all the data that you have in your ADW and visualize on it. Let's see how we do that for the wine data set. So you create a project and you select the test, the connection that you created. So here it is. Now you'll see all the schemas that you have in your ADW and select the schema that you want that the table is. And here is a search bar, so you can look for all your tables. So I'm going to select this. It will show me all the columns that are there in the table. I'm going to add all of them and click on Add. It's going to give me a warning as it's already there in my OAC. So I'm just going to replace it, say yes. So OAC profiles the data and gives you recommendations also for each of the columns. I'm going to hit on Visualize, and now let's create some visualizations for the wine data set. So in the data set, we have country and we have price. So now let's see what's the average price over the country, and I'm going to use a map to visualize it. I'm going to change the aggregation to average. So you can see the bar at the below that shows the minimum and the maximum. So for all the wines in the data set, we have minimum price of $9 going to $85, and the darker the shade of the blue, the higher the price. So if I hover over the map, it shows me Switzerland, which has a high price of 85.29 for a wine. I can filter on, in OML, we created a model and we did predictions. So whether a wine is good or bad, like whether the wine is greater than 90 points or less than 90 points. So let's filter it. So you can see the price has changed. So a good bottle of wine, the minimum that you have to shell out is $38, going up to $160, with Switzerland still being the country that has $160 for a wine. I can easily duplicate this visualization and change it. So instead of country, I'm going to put variety, and let's see what variety of wine can we get for what price? So if I zoom in over this region, I can see Champagne is $112. A Bordeaux is approximately $80. So we have got a good idea of, in general, which country has on an average what price of wine. Now let's see, I'm going to show the percentage of wine and the average price and compare it with less than 90 points and greater than 90 points. Suppose if you don't want to shell out much for a wine, then where would you go? So I'm going to filter it and let's say less than 90 points. So I'm going to now duplicate this so that I have a comparison between greater than and less than. So we can see that in France, for a good bottle of wine, I have to shell out $82. But for an okay wine, $20. In US, similar to France, on an average, 22.64. In Italy, for an okay wine, $23. And for a good bottle of wine in US, approximately $50. And in Italy, you would have to shell out more, $74. With this, I'll pass on to Siddesh so that he can show us more cool visualization.
Okay. Thank you, Dhvani. So now that we've seen some of the wine varieties across the world, let's look at it from a specific country's perspective. So if I say, for example, for any wine person, you would know, like if you take France as a country and check for the price, you will see that we will see how whether it's a good wine that is greater than 90 points or not so good wine which is less than 90 points. So I'll just put price here and then add a prediction as my filter, and I'm going to choose a horizontal bar greater than 90 points. And as I said, let's take France, for example, because as Dhvani talked about, there are many, we are focusing on France from the world's maps perspective. So as you can see, if you want to have a good wine that is greater than 90 points, the minimum that you have to shell out is $21, and the maximum is around $113, as we saw. And now, say for example, you're going to a particular party and you don't want to shell out $113. You would want to like look at other, if you're okay with not so good wine, but you're looking for a cheap wine basically. So I'm going to change the filter here, make it less than 90 points, and you can see that on the horizontal axis, you can see the scale is changed, and the maximum price that you would shell out here would be around $47, and the minimum for a Moscato would be like around, I think, $7.50. So by this, you can make out that if depending on what you want to do, like if you want to have a good wine which is greater than 90 points and you're okay with shelling out more money, then you go with champagne blend. Otherwise, you can either choose, depending on what price you're going for, you can choose a champagne, another variety of champagne blend which is much cheaper. One more visualization, that gives you more insight would be, so if you know a particular variety, say for example a Cabernet Syrah, say I'm going to use that as an example. So in this, using this particular variety, and you want a good wine, you need to know which parts of the world you get the good wines. So for that, I'm just going to use country and province, price, and ID. So this, And you need to know how probable it is. Like, so for a good wine that is greater than 90 points, you need to make sure that you, how often you get that how often that wine is good, greater than 90 point wine. So you can see here that for a Cabernet Syrah, you can, the probability of it being a good wine, and you have to, and finding it in Spain, and you have to shell out like $35. So through this, you can make sure that if you are a wine person and you have you know a particular variety, then you can see how much you need to spend if you want a particular good wine. With this, I'll throw it back to Charlie.
All right, thanks, Siddesh and Dhvani. That was really great, and you are making me thirsty here. So what I'm going to do now is share and say yes, I do want to share the other. So now I just wanted to show, I was having some sort of network problems here. I was a little bit sort of concerned about this that didn't actually finish, or whatever. It did finish 1 minute and 36 seconds. And so I just wanted to kind of close out that I did get that to finish, of course. And I wanted to go back to sort of wrapping up. If you find this interesting and useful, there's a lot of helpful links out there you can go to. Of course, the Oracle Autonomous Cloud, where you just click on that link. It's in the chat window, so you can just go directly there and you can just try it out. We've created some hands-on labs. There's another one for credit, identifying customers with credit, likely to have very good credit. And it's just a complete sort of beginning, middle, and end of how to tackle a problem using autonomous, using machine learning, using OAC to interrogate the results, much like what we did today in a simpler example, but that's a great one. You can see more information up on OTN. There's some other tutorials here. Actually, this is the specific lab for machine learning that's available in this sort of broader one. And then on the Analytics Cloud, there's a number of great examples out there for visualizing this data set and that data set, and it's really great. So please take a look at those things. Continuing on, for future TechCasts, we should have Tamia Turdian, software engineer from Semantic Web, talking about using Oracle Spatial and Graph in very clever ways. She was kind enough to share with us skills and expertise. And we really do encourage you to submit your own TechCast. This whole thing is not meant to be just a demo or a sales pitch or whatever. It's really meant to be sharing. There's a lot of us that use Oracle technologies to do amazing things, but each one of us has their own sort of tips and tricks and skills. Last week, we saw a great one from Wayne Van Sluis about custom data visualization add-ins or plugins in OAC. So things like that, things like hopefully you found this is useful. Submit things like that. We've got a backlog of TechCasts now that we're sifting through and picking out the best ones for you. And I encourage you to submit something there and share it with us. Lastly, as you hopefully also know, Dan and I and others run these physical on-premise kind of events once a year. The next Analytics and Data Summit out at Oracle HQ will be in February, the end of February. Please mark your calendars for that. With that, I think I will turn it over to Dan to close us out, and we'll look at the Q&A for any additional questions that you may have submitted there. I'm not seeing too many questions.
Charlie.
Really so far.
Charlie, we did have one question that came in. Shankar says, any use case wherein the output of the OML model prediction is further acted upon using the the machine learning capabilities of OAC? For example, classification, build, model build, and apply in OML. See the results, build clustering model over the brands, say in OAC. Both have that capability. Leveraging both types of machine learning should get us to go further. Any comments on that? Not sure if that's a question or a comment on that.
Well, I think that's what we're trying to portray now. Maybe Shankar, you were thinking about doing more sort of involved and complicated ways of maybe having a REST API call something as a trigger or something. And certainly with the Oracle database and such, you can do those kind of things. This was trying to show that I could have predicted which ones were the best ones, and I could have done some further clustering, and who knows what you can assemble, because we bring the algorithms to the data management platform and we now make the Oracle database much more of an AI thinking kind of database that is so much more capable of not only storing and managing your data, but also analyzing it using powerful in database implementations of algorithms. You can do so much more. We support R integration, and we'll have Python. We have notebooks. We have drag and drop GUIs. But under the hood, they're all running as scripts or SQL functions, actually. So you can assemble, just like you can assemble any, the way that the Oracle database undergirds so many different things. You can assemble to your heart's content very involved analytical methodologies. We do that with more and more applications these days, and then the way they surface those could be through the application. They could surface the results through OAC. They could review our findings and distillations and such, just as the way that Dhvani and Siddesh just showed today. But there's a lot of different options. The idea that we're trying to portray here is there's a lot of analytical horsepower that's built into the Oracle technology these days, and together, using all these different components, you can do a lot of very cool things. So hopefully that was a long-winded answer to your question.
Yeah, thanks. Another question came in while you're answering that, and people feel free to put those in. We'll leave it open for a little bit here. The real trick here seems to be knowing that you should use random forest. Is there any guidance on knowing what machine learning model to pick?
I would say that there wasn't any real trick to use random forest. We just used random forest because it was a cool algorithm to use. A lot of people know random forest. We have it inside the database. We used it in some of the other notebooks that we have out on GitHub. If you look at, there's one that Siddesh and Dhvani and I have collaborated on. I think it's called Targeting Top Customers, and we use this credit scoring 100 data set, and we actually go off and very mechanically, if you will, run a random forest. We run a logistic regression. We run a decision tree, and then we kind of compare the lift charts and the accuracies of all those, and make a determination of which model or which models we want to use for our predictions. Maybe we want to have a panel of experts, but sometimes it's a very involved process. Not involved. Any one of them is going to be doing better than not doing any predictive modeling. But sometimes it's a judgment call. With the Oracle machine learning algorithms, sometimes people would pick a decision tree because it sort of gives these explanatory rules. But we've added something called prediction details that does that regardless of whether or not using a neural network or whatever. So you can run them all exhaustively and compare them. I think they'll all do really pretty well. Going forward, we have some stuff we've talked about. We'll be talking about more at Oracle Open World called AutoML that just sort of shotguns a lot of different models and figures out which is the best one for you. Does a lot of automated feature selection, hyperparameter tuning, and so on. So we're doing more and more automation there, but any one model, or you can compare them. You can do whatever you want.
Okay, thanks. Another comment, there's no free lunch. You have to pick what you want. And also, it'd be interesting to see a scatter plot with the score and the price on the axes and the country, region, varietal as the points, and find the outliers. That's from Tim Vlamis. So
yeah, that's
another way of looking at this.
We may come back. This data set it actually has a bunch of customer or reviewer comments, like it's a cherry or fruity flavored wine. So the people that did review them, the wine spectator kind of reviewers, there's a bunch of unstructured comments on that, and we hope to come back and show how we can do the same thing, including the unstructured data as well. That's a new capability that got turned on in the autonomous database recently. We didn't want to make this first TechCast too complicated, so we'll come back and show that, or some other things that do it in a more complicated way.
Well, Charlie, that's what I see in terms of comments and questions that have been answered. Let me go ahead and start wrapping up here, unless you have anything else to share.
No, that is it. Just the future TechCast and submit your own.
Yeah, we'd love to have you all, join everybody in the audience. Let me thank Charlie Berger, Siddesh, and Dhvani for sharing how to pick a wine for under $20. Appreciate that. If you're interested in this type of information, this is our second TechCast in our reboot of the series. Go to analyticsanddatasummit.org/techcasts. I'll be presenting soon on new features in the Oracle Analytics Cloud version 5.3 that just rolled. Look on that for an update on the dates on that, and look forward to having you all join us. And please register for the TechCast and watch that page for additional stuff as it comes out. And thank you, everybody, for joining us. Goodbye.